Hi everyone. Today we're doing notes for 3.6, solving linear equations and simplifying expressions. So linear equation in one variable is an equation that can be put into the form mx plus b equals 0. So essentially our y equals mx plus b, we're just setting that equal to 0 instead of having the y equals in front. If you have an equation and every term is either a constant term or an x term, then the equation can be put into the form mx plus b equals 0. So for our first example, explain why each of the following is not a linear equation in one variable. For this first one, we have 4x squared. So the 4x squared, that's actually a quadratic term because we have the x squared, and so that's why that one is not linear. For b, we have y minus 2x equals 10, and so the y is actually, we have two variables, and so that's why that one is not a linear equation in one variable. It's important to recognize the difference between expressions and equations. So this first one, 4x plus 10, this is an expression. 4x plus 10 equals 22, this is an equation. An expression will just have combining terms like multiplying, dividing, adding, or subtracting. An equation will always have the equal sign in there as well. So we evaluate expressions and we solve equations. So for this next example, we have to evaluate 4x plus 10 for when x equals 5. And we can do that by taking our 5 and plugging it in for x. So 4 times 5 plus 10, that's going to be 20 plus 10, which is 30. Is x equals 5 a solution to 4x plus 10 equals 22? Again, we can check this by plugging it in and then seeing if it's true or false. 4 times 5 plus 10 equals 22. That's 20 plus 10 equals 22. And 30 equals 22. That's not true. That's false. So x equals 5 is not a solution. A number is a solution to an equation if the equation becomes a true statement when the number is substituted for the variable. In other words, the solution is the answer. Doing the math to find the answer is called solving an equation. So we have to solve each of these equations. So for this first one, we're going to combine our like terms first. 4x minus 9x is negative 5x plus 3 equals negative 22. Then we subtract 3. Negative 5x equals negative 25. Divide by negative 5. And x is equal to 5. For our next one, I'm going to subtract 3x to start. So this cancels. 2x plus 4 equals 16. Then we subtract 4. 2x equals 12. Divide by 2. And x is equal to 6. For our last one, we simply add 16.59 and we get x is equal to 41.76. All right, so to solve linear equations and simplify expressions. So we're continuing here. Now we have some that are a little bit more complicated as we're solving. For D, we have to distribute first. Then we can combine our like terms. So I have 1 minus 15b plus 6 is equal to 4 minus 7b minus 3. So 1 plus 6 is 7 minus 15b is equal to 4 minus 3 is 1 minus 7b. I can add 7b. 7 minus 8b equals 1. Subtract 7. Negative 8b equals negative 6. Divide by negative 8. And b is going to be equal to 3/4 or 0.75. For our next one, I'm going to rewrite 1/3, so I have a common denominator. I know 1/3 is the same as 3/9. So I'm going to add it as 3/9 to both sides. So I have x over 9 is equal to 2/9 plus 3/9 is 5/9. And so because these are both over 9, x over 9 equals 5 over 9, we can see here's our solution. X equals 5. For this last one, I'm going to put my negative 2x over 1, and then we can cross multiply. So that's just times 1. So I have 3 times x minus 4 is equal to 5 times negative 2x. So this is 3x minus 12 equals negative 10x. I'm going to subtract 3x. Negative 12 equals negative 13x. We divide by negative 13. And we get x is equal to 12/13. Next we are going to go over how you can solve an equation by graphing. So you set each side of the equation equal to y. You graph each equation using technology or using Desmos. Find the intersection of the two graphs. And then the x-coordinate of the intersection is the solution. Okay, so for this first one, I'm going to rewrite these. I'm going to do the left half, y equals negative 1/2 x plus 1. And then the right-hand side is going to be y equals 3. So if I graph both of these in Desmos, I have y equals we have negative 1/2 x plus 1. My second one, we have y equals 3. And so I can see that this point right here, negative 4, 3, is where they intersect. So these intersect at negative 4, 3. And remember we said the x-coordinate is the solution. So my x equals negative 4. I'm going to do D as well to show you. So we're going to graph y equals negative 3x plus 7 and y equals 5x plus 15. So our first one, we have y equals negative 3x plus 7. The second one, we have y equals 5x plus 15. And so we can see our solution is right here. It's negative 110. And again, our solution is the x-coordinate, so it's negative 1. I want you to pause the video and try to do B, C, E, and F. All right, hopefully you've worked through B, C, E, and F. So B, you're going to rewrite y equals negative 4x minus 1 and y equals negative 8. The solution is 3, negative 8, so x is 3. For C, you're going to rewrite as y equals 5x minus 3 and y equals negative 8. Your solution is negative 1, negative 8, so x equals negative 1. For E, y equals negative 2x minus 3 and y equals 3x plus 7. The point where they intersect is negative 2, 1. So x equals negative 2. And this last one, y equals x minus 4, and y equals 1/5 x. They intersect at 5, 1, so x is equal to 5. Okay, here's another way you can do this. You can use a table to solve the following equations. So I have 5x minus 3 equals 12. So I'm going to look in my table where y is 12 and the x value is 3. So x equals 3. Similarly, for b, 5x minus 3 equals negative 13. So I find negative 13 in the table, and I see x is negative 2. All right, we're going to simplify expressions by combining like terms and using the distributive property. So for a, I have 2b minus 15b minus 6 plus 1. 2b minus 15b is going to give us negative 13b, and then negative 6 plus 1 is negative 5. For the next one, we distribute first. We get 12x minus 18y minus 36x minus 20y. 12x minus 36x is negative 24x. Negative 18y minus 20y is negative 38y. For C, this is 3/5 x minus 3/5 plus 1/5 x plus 1/5. 3/5 x plus 1/5 x is 4/5 x. Negative 3/5 plus 1/5 is negative 2/5. I want you to pause the video and try to do D, E, and F. So I'll show you your work for each of these in the solution. For D, we have 5x minus 2x minus 3, which simplifies to 3x minus 3. For E, we have negative x plus 4y minus 7, and that's actually as simplified as we can get. None of those are like terms. And then for F, when we combine like terms, we have negative 4x plus 8y plus 9. All right, so this time we have to write an equation and solve for it. The sum of $9.50 and the deductible is $17.25. I'm going to call the deductible X. So if I want the sum, that means addition. So $9.50 plus X equals $17.25. So that's our equation. I'm going to copy it over here. And so to solve, I'm going to subtract 950. And I get X is equal to 775. So since X equals 775 makes the equation true, X equals 775 is a solution. Next one, the product of -5 and a number is -1.5. Write an equation and solve it. So for a number, I'm going to call it X. Product means multiply. So I have -5 times X equals -1.5. So that's our equation. I'm going to copy it over here. We divide by -5 to solve. And I get X is equal to 0.3. So since x equals 0.3 makes the equation true, x equals 0.3 is a solution. All right, so looking at our scatter plots again, if we're looking at the R value is the strength of the linear relationship between two variables. The R squared value is the coefficient of determination. This is a statistical measure of how close the data are to the fitted regression line. Whereas correlation explains the strength of the relationship between an independent and dependent variable, R squared explains to what extent the variance of one variable explains the variance of the second variable. So how the calculator computes the regression line. It finds the mean of the x and y coordinates. This is one point on the line of best fit. Using this fixed point, you tilt the line back and forth until you find the slope that will make the sum of the squares of the residuals as small as possible. Because the equation for the line is an estimate, we use the hat notation. So again, it's going to look like y hat of x equals ax plus b. We've talked about these words before. Again, interpolation is predicting values that fall within the range of data points. Extrapolation is predicting values for points outside the range of data points. Interpolation is likely to be more accurate than extrapolation. The further you extrapolate from the given data, the more inaccurate your predictions are likely to be. The closer you are to a known data point, the more accurate your estimate is likely to be. So here we have one final example, and we need to find the linear regression line using technology. Do not use commas when entering the data into technology. So I'm going to put this into Desmos. You can follow along with me. So we're going to put in our data in a table. So we're going to put our weight of cars in the X's. So 2948, 3536, 3472, 2782, 3766, 4367, 2649, 2526, 2665, and 3374. Then we're going to enter our Y data, 23, 19, 19, 20, 14, 16, 21, 23, 25, and 21. Now remember, you can hit the plus sign here so we can see our graph on a scatter plot. And so if we want to find the linear regression line, we're going to type y1, then we're going to use the tilde symbol, and then we're going to do m for our slope, x1 plus b. Okay, and so now we can see our line of best fit, and we can see our m value we're going to use for our slope is negative 0.0046, we'll round that to, and our y-intercept is going to be 34.74. So let's write that. So we have y equals negative 0.0046x plus 34.74. What does the model predict for highway fuel efficiency for a car that weighs 2,948 pounds? So we're going to plug this value in for x. So we have y equals negative 0.0046 times 2,948 plus 34.74. And so when we plug this in, we get 21.1792. So that's about 21. Now, if we look at our table, we see for 2,948, the actual value was 23. So that's close. We can also look on our graph and we can see where that is. Again, all right, 2,948. That one is right here. And so our line predicts it to be about 21, you can see, slightly lower. Should the model be used to predict the highway fuel efficiency for a car that weighs 4,500 pounds? Why or why not? So if I look at my graph, 4,500 we can see is past the data. We have these 2 points that are, slightly higher numbers. The highest data point we have is 4,367. So that's not too far away from 4,500. However, those 2 points are a little bit farther than the rest of the data. So I would say in this case, no. Again, we have 4,367, 16 is already farther, or I'll say far from the majority of the data in the set. And so 4,500 is outside the set, and we do not want to extrapolate as it may not be accurate. And that's the end of our notes for today.